Hello and welcome back to Calculus 3. Today's section on dot product and later on cross product. Now let's see what's happening here. First of all, what is the dot product? You are used to the product being 2 times 8 equals 16. And I would say yes, that's one-dimensional product. What happens if you have two-dimensional product? How do you multiply a vector, a 2D vector, with another 2D vector? So you can think of this as one-dimensional vector 2 times another one-dimensional vector 8 to get one-dimensional answer 16. That's still valid to write. These one-dimensional vectors, they have no direction. They do have magnitude. So 2 times 8 is 16, and that's all we have. But now we can also look into, let's say, 2, 3, dotted with -5 and 8, which is a two-dimensional vector times another two-dimensional vector. It's important to understand that the answer over here was a scalar quantity, meaning it's just a number. So the dot product, as you've seen while doing the class prep, will be 2 times -5 plus 3 times 8, which gives us -10 plus 24, which is 14 in this case. So if you are to multiply two vectors, you are going to get a scalar quantity at the end. Now, I would like to introduce the dot product using the calculation. So we have u dot v, which is u1 u2 dot v1 v2, and that is equal to u1 times v1 plus u2 v2. That's how we compute it. It's a definition. Dot product works in any dimension. Which means that we can do this also if u and v were three-dimensional vectors. To get, again, the same u1 v1 u2 v2 plus u3 v3. So that's your 3D version of the dot product. I know it's a trivial exercise, but maybe you need it to feel accomplished, you know. So what's the dot product between these two? Didn't you just want to say minus 6? Change the negative. You all have 7? No? That's good because you will be wrong. What's the answer? Negative 6. Good. So one of the forms of the dot product is going to be u dot v is equal to magnitude of u times magnitude of v times cosine theta. Theta is the angle between vector u and v. So I hope you see that we can use this one to compute angle between two vectors. So this is another way to look at the dot product, from where we can compute theta as the inverse cosine of u dot v divided by magnitude of u times magnitude of v. So let's find the angle between angle theta between vectors u equals 315 and v equals -2, 0, and 2. So find the angle between these guys. You can give 1 decimal point precision for degrees. So round to the nearest tenth in degrees. Yes.
Have you ever taught linear algebra?
Yeah.
Are you thinking about teaching it next spring?
Guys, relax me a little bit.
Just think about it next fall. You're breaking my heart here. Can you replace Ford right now? Yeah.
Nothing to worry about. It's just proofs.
Are they as bad as like high school proofs? Like proofs that this triangle is congruent to this one?
No.
Or is it like proofs what we did in Calculus? You're okay if like we come into your office hours, like even if we're not taking okay.
All right, so we are going to need two magnitudes, right? So magnitude of u is the square root of 9, 10, 35. Magnitude of v is the square root of 8. So our angle theta is inverse cosine of the dot product, which is 4, divided by the square root of 71, 40, 280. I think it's good enough. Well, actually, wait, this should be 2 root 2. So 2 root 70, which is cosine inverse of 2 over root 70. Now we can change calculator to degrees, the mode. By the way, if you have the correct technology, you can download the app for TI 80 whatever or 90 whatever onto your phone. No exams, sorry. But you can use it. I mean, let's say you go out. You're not going to bring your TI 83, 84 with you. But you definitely bring your phone. So, you know, if you have right technology, you can do that. Exactly, because eventually, Alex, one of those questions, what do you know, pops out. Right? You immediately, you're just ready. All right, divided by 70. I have 76.2 degrees. Yes? You can actually leave a cosine -1. For exam, you can have the scientific calculator, which will compute this. Right? Scientific calculator does compute exponential, logarithmic, and trigonometric functions. But you can also leave it as this. Unless the question asks for 1 decimal precision, 2 decimal, right? In that case, yeah.
Did you show how you had the root 35?
3 squared is 9. 1 squared is...
Got it. I got it now.
Yay. Direct consequence of this formula is a theorem which states that if the dot product between two vectors is 0, those two vectors are
0.
well, yeah. Perpendicular. Nice. So, theorem states if u dot v equal to 0 implies u perpendicular to v. 90 degrees between these two vectors. I just abbreviated everything. You have the class prep, you have your textbook, so you know what I mean. So u dot v, say it's 130 dotted with negative 3, 1, 0, no 10. The dot product between these two vectors is 0, right? Because you have negative 3 plus 3, and then 0 times 10 is 0, so they all add to 0. The dot product over here is 0, which implies u and v are perpendicular. Now this is going to be useful later on in the course. You want to remember this. We have some properties. Of that product. Number one, it's commutative. Number two, we have associative property. C is a constant, obviously. And three, we have distributive property. So those are the properties of dot product. Again, you can prove each one of these if you simply replace u with u1, u2, v with v1, v2, and then just grind through algebra. Orthogonal projections. Remember how we talked about pushing the crate? Well, if you have a crate on the ground, you have a crate on the ground, and you know that you are going to push it with some force like this, which decomposes into two forces, the forward force right there and the force that is trying to bury the crate into the ground. It is this component here that pushes, and this one over here is the waste, or even worse, we showed yesterday that it makes the whole situation of pushing the crate worse because it makes the whole thing heavier. Remember the normal force and friction and everything we did, what we outlined. So what is the component which actually does the work? It is the horizontal component because you get to push the crate forward. Now we can compute that quickly by projecting the force, vector for the force, onto the direction in which the crate can move. So if you think about it, I'll erase this blue line eventually. This blue line here is, since I will be touching at the corner right there, this blue line is the direction in which the crate could go forward or backward, right? So if I'm applying the force on this side, it is only this component, the x component, that does the work because the crate is moving. So if I want to, I can use mathematical orthogonal projection idea to compute that vector. And you can do that by simply shine the light above, and you will see which line, right, the shadow of this on the blue line is the projection, which is how much force out of everything that you're putting out is actually going towards pushing the crate. So we have a formula. Now, derivation of this formula, again, if you are taking the honors option, you'll take a look and learn the formula. I want to just write down the final version of it. So, projection of the vector u onto vector v is given by u dot v divided by v dot v and everything times v. Now, this obviously means nothing without a little sketch to accompany this. So if I have some kind of a vector v, and then I have somewhere vector u, we are going to find the perpendicular So we read this part, projection of vector u onto vector v. So v is the base, and you are projecting u onto v. So the final answer will have to have a direction of v because you are projecting on it. But the magnitude will depend on the length of u, which is vector u. So let's just quickly practice this. So here are the two vectors. Let's say again 2 and 3. So u is 2 and 3, and v is negative 1 and what? Which number should I put? 6 it is. It's first come, first serve. Next time be faster. Now I want projection of u onto v, and I want the projection of v onto u. It's just plug and chug. You'll have to memorize this formula if you don't want to, figure out the derivation for it. Just
Did she say hi to him or any of us?
no.
I'm so sorry.
You're sitting next to
I sat next to you. You know what perfume she puts on? Oh my god.
I will never forget that day.
He covered up his face.
That was but still, I think you exaggerated a little bit.
No.
You ever been?
Yes.
She felt so uncomfortable when you guys started moving away. She sprayed the perfume and you all went like, I just like,
It's so good, but like, hang on. There's this thing that like that happens in high school and mainly in middle school. It's called axe bombing. It's when there's a bunch of prepubescent middle school boys, and they just got out of gym and they have cans of that Axe body spray and they just like go at it. Yeah, you think I'm exaggerating, but
If you take out the top,
right, just like dump it.
if it's a V on you, is it VF over?
I'm you. So it's gonna be all of the U's and one.
Yeah, so this would, how would this, like, the final answer would be that bracketed thing, right? Because this comes out as a constant, and that's a vector. Okay, so it's just the vector component. Alright. That wouldn't make sense. Thank you, Brad, by the way. No, just look at the picture here. No, I did.
Oh, and if you multiply the numbers by factor, you get like the first number multiplied by the thing, you get a vector. It's not a number, it's a constant.
Yeah, that's
Negative.
No, hang on. It's the vector component.
Is that pi?
Hang on. I got negative 16 or 37 comma 96.
Do you want to do it?
Yeah.
Right, so okay, you dot product the first.
Hang on.
You take two comma eight. Right?
Wait, no.
What? Dot product two times two.
So is the answer going to be a scalar or a vector?
Vector.
Vector, right? The answer is a vector because we are projecting one vector onto another vector. We're just changing its direction and the magnitude.
Okay, what'd you get for the dot?
16, and on the bottom I got 37 1 and then 13.
Wait a minute, right.
Who's getting 37?
U dot B is 16. Like B dot B.
Yeah,
is-
you know, so 36 plus 1. Is that magnitude?
No, it's not right.
Hey, oh yeah. Yeah, we can photo.
It's not magnitude.
Because somebody can't plan properly.
It's not right.
Yeah, but maybe
All right, I can sense some disturbance in the force, so let's compute this together. Is everything okay back there? You guys look concerned. Why? You all good? All right. So we have U dot V divided by V dot V, everything times V. There we go. So it's 16 divided by 37 divided with -1/6 to get -16 over 37. And 6 times 16, 36, 96. So do we all have -16 over 37 and 96 over 37 for the first one? Bueno. Now, projection of vector V onto U. Well, that's going to change our formula to U dot V divided by U dot U times vector U, because now U is the base and we're projecting V onto it. So we still have 16 on top because U dot V or V dot U, same thing. Now U dot U is what? 13. And then we dot that with vector U, which is 2, 3. For the final answer of 2 times 16, 32 over 13, and 3 times 16, 30, 48 over 13. Done deal. Oh, you're gonna leave now? We're gonna start physics.
Nina said she's coming to dog.
Sounds good to me. There's no chairs. Actually, no, that would be good. She can sit in the corner. I'm used to that. So, let's do some work. Work is defined as force times the distance, right? Right. So, work is force times the distance. Now, why is the distance a vector as well? Well, when you are on the flat surface, There's just the magnitude that counts, right? How far you have to push. But what happens if you're on an incline, right? Then it matters. The distance becomes a vector. So if you are pushing a crate on the flat surface, right, we don't care about distance being a vector because of the zero elevation. So it's just how far we have to go. But then if you are on the incline, let's say for some reason you are pushing something up to 30-degree slope, and you are applying the force like this, force F, you can see that the distance now it's a vector that goes up at 30 degrees. So to move the crate from one point to another, right, you have to go the distance on the surface of the ramp on which you are, where the force is applied at the angle. Now you can use linear algebra to rotate these systems and to, I'll draw another picture. But the interesting part here is that you can immediately convert the dot product formula and use the angle that is immediately embedded in the formula. So you know that the dot product can also be found with the magnitude of the force times the magnitude of the distance times the cosine theta. And that's that part, the benefit in physics. So you know with what force you're pushing, you know how far the object goes and at what angle, so you can calculate the work. Now, those are the things that you can actually measure, right? So how much force you're pushing, how far you went, and what's the angle of the incline. If the angle of the incline is 0, what's cosine of 0? 1. So you see it works beautifully, right? So all of the force with which you are pushing is going to push the crate. In this case over here, not all of the force, right? Because cosine of 30 degrees is what? There we go, much better. Button up, button up. Now, one more picture. Let's go again on the incline. For those of you who did not enjoy physics yet, this is going to be an interesting example. So, I'm not going to draw too much of the crate now because I need to show forces. So we have the weight of the crate, which is mass times gravity, mass in kilograms, and then gravity of the planet, on average 9.81. You have the force down the incline. You have the normal force, which is responsible for friction, which is mu kinetic times the normal force. And now if you look at this, The way to solve these problems in physics is sum of all forces in x direction needs to be 0, and sum of all forces in y direction needs to be equal to 0. So whatever is given, you can always figure out whatever is missing. Now, if you look at this, on the incline, you have 3 forces that are, so these 3 forces are not on level, right? With x and y axes. Only one force, the weight, is aligned with the y motion. So you would have to break 3 forces using trig, using 30 degrees in this case, and then go through sum of all forces. Now this is where math is helpful, because what you could do, if you're clever enough, is you say, I'm just going to look at the crate and call this force down the incline, and the normal force would go like this, and the friction force would go like that, in which case the weight force is the only one that will be at 30 degrees. So you rotate the entire system by 30 degrees, which is going to set 3 forces into. So now you see that force down the incline, the friction force, and the x component of weight are the forces that you need to add to 0. So force down the incline and the weight component x work together to add and counter friction. And then you have the normal force and the y component of weight to cancel each other out. You write those 2 equations, and now you have to use trig. Instead of using trig 6 times, you have to use trig only twice, which is huge savings. So that's why we study mathematics and try to figure out much faster and better ways to solve problems. Now, if you take linear algebra, you rotate the entire coordinate system, and you plug all of this in one matrix, and you get it done immediately, which is what you can program later on. And
we'll do it
take
later.
A picture?
I don't feel good.
You don't feel good?
No.
All right. Like you miss one trig value and you immediately don't feel good. Okay. What was I talking about? Oh yeah, that's it. So that's physics. And we're done. That's 11. I hope you're not disappointed, but that's 11.3 dot product. Fine? All right, bye stream, and we'll see you soon.